Find Fourier series of f of x equal to x in the interval minus pi comma pi. In the starting of the Fourier series problems, in the first video, we determined Fourier series to the function x in the interval 0, 2 pi. There we calculated a0, an and bn, the three Fourier coefficients, and we used those values in the expansion. That is f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. In this expansion, we substituted the three Fourier coefficients. We got the expansion to the function f of x, that is for x. If they ask Fourier series in the interval 0, 2 pi. Here they ask a Fourier series to the function in the interval minus pi comma pi. If the interval is 0, 2 pi, compulsory we have to calculate the three Fourier coefficients. But if the interval is minus pi to pi, we have chance to check whether f of x, the given function, is even or odd. If the interval is minus pi comma pi, first we check whether the given function is even or odd. Here the given function is odd function. So since f of x is odd function defined in the interval minus pi comma pi, its Fourier series contains only bn terms. Suppose if it is x square, in that situation it becomes even. F of x is even function defined in the interval minus pi comma pi. In that situation, its Fourier series contains only a0 and an terms. By keeping this point in mind, solve the problem. We have chance to check whether the given function is even or odd if the specified interval is minus pi comma pi. If the interval is 0, 2 pi, compulsory we have to evaluate a0, an and bn, three Fourier coefficient. But if the interval is minus pi comma pi, once check the given function is even or odd. Accordingly, find Fourier coefficient. Here, since f of x equal to x is an odd function defined in the interval minus pi comma pi, Fourier series contains only sine terms. That is, Fourier series of f of x equal to sigma bn sin nx n equal to 1 to infinity. This is the required Fourier series to the given function. So it's enough if we calculate bn. See, if you have any doubt, if you try to calculate a0 and an in that situation, you will get zeros only. So no need to determine. So here bn Fourier coefficient equal to 2 by pi integral 0 to pi f of x is here x sin nx dx. Now evaluate this integral. Under the integral, product of two functions, one of them is algebraic, another one trigonometric. Take u as x, v sin nx. Here u equal to x, u dash becomes 1, u double dash 0. v equal to sin nx, v1 equal to integral of sin, that is minus cos nx by n. v2 equal to integral of cos is sin nx by n square. By the generalized rule of by parts, integral uv dx equal to uv1, u is x, v1 is minus cos nx by n, uv1 minus u dash is 1, v2 equal to minus sin nx by n square, uv1 minus u dash v2 plus u double dash. As it is 0, the next term 0. The formula will be stopped. Limits are from 0 to pi. 2 by pi. Here minus x into cos nx by n minus plus sin nx by n square. Limits are from 0 to pi. Now by substituting the upper limit pi, here minus pi cos n pi value minus 1 whole power n plus sin n pi value 0. This is upper limit substitution. Minus of lower limit substitution 0 in place of x. 0 into something 0. Sin 0 0. So simply lower limit substitution 0. It is equal to, here pi cancel. So 2 into minus 1 whole power n by n. This is Bn Fourier coefficient. Therefore Fourier series of f of x defined in the interval minus pi comma pi is given by sigma n equal to 1 to infinity Bn sin nx. We got Bn Fourier coefficient as 2 into minus 1 whole power n by n. So as a 2 is free from n, write down outside of the sigma minus 1 whole power n by n sin nx. Here f of x they given x. This is the required Fourier series expansion to the function x in the interval minus pi comma pi. I am again repeating that you have chance to check whether the given function is even or odd if the interval is minus pi comma